Hey guys, once again, it's Mr. McComb here coming at you for some science. It's our Tuesday science video going through a few pages. Today what we're going to read and cover are 258 to 261. Forces, more to do with forces. This is an important page here we're going to focus on, and we'll take a quick look at the next ones after that. Yesterday you watched a video, thanks for watching that, about mostly gravity and friction and just kind of what forces are. Again, any push or pull that results in motion or can cause motion. We need forces to cause motion to happen. Today we're going to talk about some cases where we might actually have forces, but maybe motion doesn't happen depending on the situation, okay? So the big things here today are talking about balanced forces and unbalanced forces, okay? So first of all, if we look at balanced forces, it says balanced forces are forces on an object that are equal in size and opposite in direction. And the big sentence here at the end, it says they cancel each other out, okay? What they mean by that is when we have balanced forces, that's when forces might be applied to an object, but there's no motion happening, okay? Great example of where that can happen is our illustration here. If we're playing Tug-of-War, if you're in an evenly matched, balanced match of Tug-of-War with two sides that are both equal in pulling. So this is a force of pulling, but if they have the same amount of force on each side, what happens there? Well, in that case, we would see that this flag in the middle wouldn't move, and so there's no motion happening. So balanced forces are cases where things are either pulling in opposite directions or pushing together in opposite directions, like this one would be going this way, this one's going this way, pushing together on an object, and they're not moving at all, okay? So balanced forces actually result in no motion happening. Even though there are forces, they cancel each other out, which means there's no motion. So again, in this case, pulling in opposite directions, pulling on Tug-of-War, even if they're pulling really hard, if they're both pulling the same amount, there's no motion that would happen, okay? Same thing could happen if you were trying to push on the same object in opposite directions. If you and a friend were maybe pushing a box across, trying to push a box across the room and pushing on opposite sides, you could both be pushing together, but that box stays still. So even though there might be lots of force, like lots of strength in pushing, if they're both going in opposite directions, balanced forces would mean that the object doesn't move. Okay, so again, think about that movement. When there's balanced forces, there's no motion happening. Okay, I'm going to put little reminders over here. Balanced means no motion. Okay, so again, this is where we can have forces, but not motion, okay? Now, the opposite of that would be unbalanced forces. Now, anytime we have motion happening, that's when we're going to have unbalanced forces acting on them, okay? So it says unbalanced forces are forces that cause a change in motion. A force must also overcome the force of friction before an object will move. So when we talked about friction yesterday, that's an example too, where friction is a force that you need to basically overcome. So that might mean if you have a box on a carpet that has lots of friction, a big heavy box on a thick carpet, you might push it a little bit, but it may not move because the friction is so great. So you might have to push harder. So we do have to overcome friction for unbalanced forces to cause motion, okay? So whenever we have motion happening, though, like again, think about Michael Jordan yesterday, he's pushing in all those different directions with his feet. He's pushing on the ball when he shoots into the basket. Those are examples of unbalanced forces. So anytime there's an unbalanced force, that's when we have motion happening. Okay, so unbalanced forces cause motion. Anytime there's movement happening, like right now when I'm typing on my computer even, my fingers are pushing down on the keys and causing it to move, which makes the images appear on the screen. Unbalanced forces are the ones we need to have motion happening, okay? So keep that in mind as we go. So if there's no motion, but there is force, those must be balanced forces. If there is motion, it's due to an unbalanced force, okay? So we're going to look through this example of using dominoes and how they might go, and just kind of going through those. And we're going to talk about whether these are unbalanced or balanced forces, okay? So it says, as we begin, we're going to kind of go through here. The push on the first domino, so imagine these are all stacked up. If you've done that, maybe you've had time to do that now since we've been home as long as we have. Stack up the dominoes, they're standing still. Once you start them off and get them moving, toppling over one another, there's motion happening there. So it says the push of the first domino was a blank force. Would that be balanced or unbalanced? That caused it to fall into the next domino. So it causes motion to happen. So what would that be? Would that be balanced or unbalanced? Well, remember what we said, for it to move, for there to be motion, it has to be unbalanced force. So this is going to be an unbalanced force. So your finger pushing on it to start those dominoes going, that's a first unbalanced force. And hopefully you can see this Unbalanced forces here that cause that motion. Again, anytime it's moving, it's an unbalanced force, okay? Then it looks like here they made a part where it goes and stops at a block. Okay, so we're focusing on this yellow domino that's stuck right up against the block. So it says the forces exerted on this domino by the falling dominoes is balanced by the force of the box. Because the forces are blank, the domino doesn't fall. So this one is already starting off right here. When this green domino falls into it, this other box that's just kind of sitting here pushes kind of in the opposite direction. And so since no motion happens, these are balanced forces. All right, so this is going to be an example of balanced forces happening, where again, there's pushing happening. That green domino that fell into the yellow one is pushing on it, but since this orange box is there, kind of basically not really pushing like moving, but pushing with having the ability to keep it from moving, that's a balanced force. Again, balanced forces result in no motion happening. So if it's standing still, but it has something pushing on it, it must be balanced forces that are causing it to happen, okay? Okay, now the last bottom part we're going to get to, it says the forces on the dominoes are blank when they are standing upright. So again, if it's standing upright, that means it's not moving. So which one would it be? Balanced, which causes no motion, or unbalanced, that causes motion. If it's just standing upright and still, that means it's an a balanced force. Again, if it's not moving, it must be balanced forces. Now we'll talk about a little bit down the road how gravity is a force that's always pushing down, but when you're standing up, with your legs and muscles are pushing back up against gravity. Even if you have your computer on your desk right now, gravity's pushing down on your computer onto your desk, but your computer table or the desk you're at actually kind of pushes back up against gravity or resists the falling, or else everything would just crumble. Okay, so when we have strong, sturdy things like tables that hold up the pull of the force of gravity, that results in the balanced force that causes no motion. But the big important thing here, again, if it's not moving, it's balanced forces, it's no motion. When we get to the last part here, it says when a falling domino hits them, the force becomes blank and they fall. So if something's falling, it would of course be in motion. So like we said, unbalanced forces are what causes motion. So that must mean that here we've got unbalanced forces acting on the dominoes. Okay, so again, big idea here. Balanced forces result in no motion. Might be pushing, but if it's balanced, again, opposite directions. Think about the tug-of-war people. If they're both pulling the same amount of force, no motion happens. Whenever we have any kind of motion, there's unbalanced forces happening that cause that. So unbalanced ones, any movement we see, we can figure out the unbalanced forces that are causing it. Okay, so there's that. Our other 2 pages are pretty basic. I'm not going to go too heavy into these, but basically it means if we push or pull harder, the more force we put on an object, the more motion that can happen as a result. So they have this example of basically a grown man and a younger boy hitting the mallet that makes the thing go up and ring the bell. So the man who's maybe more grown, stronger muscles, able to hit harder. When he does that, the motion happens more, and so the thing goes up and rings the bell. The boy might try his hardest, but he doesn't have quite as much force in his muscles because he's just not as strong or big. And so we have less motion having it may only go this far. And again, that's one of those things that kind of makes sense. If we just stop and think about it, though, basically how far we cause an object to move or how fast depends on the forces we use. So if you're maybe trying to just toss a ball to your friend who's real close, you might just kind of toss it nice and soft back and forth. If you're playing baseball, throwing baseball, if your friend is all the way across the field, you got to throw really hard. You got to use a lot of force in your arm, move it fast, use a lot of force, a big push on the ball with your arm as you throw it, make it go as far as you want it to go. Same thing with shooting baskets in basketball. If we're at the free throw line, it takes a certain amount of force. Think about if you ever tried a half-court shot. I know we always try to show off and do those half-court shots. If you do that, you got to really get that ball moving with a lot of force. And again, makes sense. If you want it to go farther, you have to use more force, okay? So that's kind of the big idea there, just to talk about, okay? This one's all about the more force we give, the more motion that happens as a result. So forces and motion are closely tied together. The last couple pages of the lesson after page 261 are some things I'd like you to look at. They kind of talk a little bit more, but in the interest of time with what we've got left, I'm not going to kind of go over those. I'm not going to require you to do it for your quiz on Thursday. So what you've coming up for me, that's all I've got for you today here. Tomorrow you're going to watch a neat Bill Nye video about science and sports in motion and how we use forces for different sports. It's a really cool video. I love this show every year. I'm sorry I can't watch it with you, but check that link out links to a different website. It's not a YouTube video. It's on Info Ohio, like an Ohio Department of Education website. But use the link and check it out. It's really cool. I'm not going to make you take notes or anything like that. I just want you to watch that tomorrow. So hopefully I'll make for a nice, easy Wednesday of science. But again, you'll see how things like we use motion for, we use forces for motion, sports, obviously in motion. It's all about this science stuff we're covering now, which is just another area of science that's really fun to study and learn about, because we can kind of think about the things that we do in our normal lives, and definitely playing sports and being active is an important part of that. So if you're going outside today, hopefully the weather's nice. Hopefully you're able to get out for a little bit and get some exercise. Use your forces of your body to move yourself around and get active and be in motion, okay? So you got that. And again, on Thursday, you should already have the link for the quiz, so if you want to get it done early, that's fine. But just use your book. It's not like a paper quiz or anything. It just have similar questions, but just use that book to help you answer. Go back over these videos if you need to. It might be helpful too. And that's about it for me, okay? So I hope you have a wonderful rest of the week. Hope you enjoy the Bill Nye, The Eyes of Nye is the name of that TV show we had. It's a different TV series, but talks about a lot of really neat stuff and learn about athletes, how they use forces and motion to help them do their cool things on their various competitive areas. Okay, so enjoy that. Do well on the quiz. Again, I miss you guys a lot. I'm sure that hopefully we'll see each other in some form or fashion before the end of the year, whether it's online or whatever. But thanks for hanging in there. Thanks for working hard. Hope you enjoy these videos. Again, this is some fun science we're getting into. So hopefully you guys have learned a lot from it too. Okay. I'll talk to you later. Again, have a great rest of the week working on all the stuff you got. And let's go GA. All right. Bye-bye.